Hi there guys, we've got another revision topic here and we're looking at an A grade topic which is calculating volume and surface area from advanced or from compound shapes, and they're typically involving spheres, cones and other non-prism shapes. The important thing to start with on this topic before we even have a look at the questions that we're going to tackle today is to remember in the exam that there's a formula page and there's some really useful information on there that people often forget to look at. So we're going to be looking typically at the two formulae here, which are to do with a sphere, and we've got the volume of the sphere there, and we've also got the surface area, and also over on the right hand side same information but for a cone. So we're going to refer to some of those formulae during these questions. So let's have a look at our first question here. It says the diagram shows a solid hemisphere. I would imagine that point's going to be important when we come back to look at the overall question, with a radius of 5 centimetres. So halfway across here we have a length of 5 centimetres, all the way across therefore would be 10. It then says find the total, and they've put this word in bold font, so I'd imagine that's going to be important. Let's have a think about it looking at the diagram. Find the total surface area of the, and again it mentions it, solid hemisphere. What the exam question there is basically telling you is that this isn't hollow, so when we're talking about surface area, which by definition we're talking about all the surfaces of the shape, we're including this curved surface of the hemisphere, but we're also going to have a solid circular base, so we're actually going to have two surfaces that are going to contribute to the overall total, hence the bold font, surface area. The other part of this question which is important is it says give your answer in terms of pi. So this is a non-calculator paper question where actually what we're going to do is we're going to apply the formula and we're going to get as far as we can, but we're not actually going to find out a final numeric value. So first things first then, using the formula page, we're asking to find the formula for surface area of a sphere. And the surface area of a sphere is given with the formula 4 pi r squared. Now, that formula is for the surface area of a sphere, and we know that we've got a hemisphere, and a hemisphere is half of this. Therefore, this divided by 2 to half it will be the surface area of a hemisphere. But importantly guys, remember here that that's for the curved surface. We're going to need to include this disc, the circular disc underneath later. So we're going to be working on the formula 2 lots of pi r squared. So there's some constants in this formula, that being the 2 and also the pi. So actually the only value we're looking for on this question is what's the radius. And the radius was given to us earlier in the question as 5. So we end up with 2 times pi times 5 squared. So let's calculate that then. So we've got 5 squared, which is 25, multiplied by pi, multiplied by 2. 2 lots of 25, that gives us 50 pi. So an expression for the curved surface area of the hemisphere is going to be 50 pi. We've then got to remember underneath that we've got this disc, kind of like the solid base, which is circular. And we know that the area of a circle, and this is one of the formulae unfortunately you have to remember for the exam, this isn't given on the formula page, is pi multiplied by r squared. So pi multiplied by r squared, and notice how I've written that. It's not pi times r and then square the solution, it's just the radius that gets squared. So it's pi multiplied by 25, which we write more simply as 25 pi. So I can now bring together my final answer, 50 pi for the curved part of the hemisphere and 25 pi for the flat base. So the total surface area is going to be 50 pi plus 25 pi, which is 75 pi, and that's our final answer. The second question of this series asks us to look for the volume this time of a compound shape which has been made from a cone and also again from a hemisphere. It then gives us some following information. It says the radius of the hemisphere is 4, which has been given here in the diagram, and it also says the radius of the base of the cone is 4. So they're sharing the same length radius. It then asks us to calculate the volume. So there's two things we're going to need to know here. We're going to need to know the volume of a cone. So let's write that down now. Volume of a cone, and then we refer to our formula page and we find that the volume of a cone is 1/3 multiplied by pi multiplied by r squared multiplied by height. And it's important when you look at the formula that height denotes the vertical height here, not the length of this dimension here. and we're also going to need to come back to the volume of the hemisphere, which we'll do in a minute. Interestingly, with this question, give your answer correct to 3 significant figures. So they're expecting us to punch this into a calculator and work this out, so this would have come from a paper 2 exam. So now let's substitute in the values we do know for this. A third remains a third, pi is pi, r in terms of our cone is 4, so 4 squared. And then we just got to be really careful here with the height. We're told the overall height of this shape is 14. What we need to recognise here is that if the radius here is 4, then also the radius here is going to be 4, because all radii are equal. So that now tells us the height of the hemisphere is 4. 14 subtract 4 tells us the height of the cone is going to be 10. So this value here is 10. So on our calculator, we're now going to type in pi times 4 squared times 10, and then divided by 3, which is the same operation as times by 1/3. And we get the value for this of 167.5516082. And you're probably sat there thinking, well, why has he written out all of that? It does say correct to 3 significant figures. But we need to get into good habits here, and we should only ever round when we get to the final answer. So we've now got the volume of our cone, so let's move on to the second part of our compound shape, which is the volume of the hemisphere, which we know from the question above is half of a sphere. So again, on the formula page, the volume of a full sphere is 4/3 pi r cubed. Therefore, if we want a hemisphere, we're going to divide this by 2, which gives us 2/3 of pi r cubed. So let's substitute the values in for that one. So we've got 2/3 multiplied by pi multiplied by 4 cubed. All of that plugged into a calculator will give us a final value of 134.0412866. So my final total volume is going to be found from the combination of the volume of the cone, which we've already looked at as 167.5516082, plus the volume of the hemisphere, which was 134.0412866. So my overall total here is going to be 301.59289, and so on. And then it says to us, give our answer correct to 3 significant figures. So reminding ourselves that significant figures are all digits once we start counting from non-zeros. So 1, 2, 3. So my cutoff is here. So what the question's effectively saying is round this to the nearest whole number. So we've got a choice of leaving it as 301, or we round this up to 302. Our decision is made on the next digit, and if the next digit is 5 or greater, we round it up, but if it's less than that, we leave it as it is. The next digit's a 5, so we round up, so our final answer is going to be 302, which is our close rounding to 3 significant figures. Centimetres, because that's the units of the question, and volume means it's cubed, so 302 centimetres cubed.